In this video, we're going to talk about the standard deviation of a discrete probability distribution. In other words, we're going to talk about the spread of the distribution about that expected value that we calculated in our last video. And I'm going to warn you before I put the equation up, it's ugly. So in this video, I'm going to show you how to do it both by hand and with a calculator. So for the standard deviation, we're going to take the deviation from the mean, which is the data value minus the mean, or the expected value. We're going to square that and then multiply it by the probability. I'm going to do that for every data value and then add the results. And right now what I have is called the variance. In order to get the standard deviation, I have to take the square root of the variance. So the process is, after we set up our table, we calculate the mean, we make a table for the deviation, we make a column for the deviation squared, we make a column for the deviation squared times the probability, we add down that column, and then we square root the results. That's more steps than the mean, and it feels a little bit intimidating. And so the second example, I'll show you what it looks like on a calculator for those of you who struggle with tedious calculations. But I want you to see it both ways so that you know that there are options. So for this first example, the probabilities that a player will get 5 to 10 questions right on a trivia quiz are shown below. Find the standard deviation for the distribution. So the very first thing is that I need to know what my expected value is, because I know that my very first column, when I start adding onto this table for my standard deviation, is going to be x minus the mean, or the expected value. So I'm going to use a calculator to find that. Next, I'm going to do x minus the mean squared, and then I'm going to multiply that by the probability. So x minus the mean squared times p of x. For my mean, I know I just multiply x times p of x and add it up. So I'm going to go ahead and do that all in one run on my calculator. So 5 times 0.05 plus 6 times 0.2 plus 7 times 0.4 plus 8 times 0.1 plus 9 times 0.15 plus 10 times 0.1. And I get 43.4. 43.4. Why does that feel weird to me? Oh, because I'm missing decimal points. Mr. J made a boo-boo. I'm so sorry. Like, that's way too big. Let's try that again. There we go. That makes way more sense. So our mean is 7.4. The reason I knew that first calculation was incorrect is that I know my mean should be the middle of my distribution, right? The mean is a measure of center. I shouldn't get a mean that's outside of my distribution. And 43.4 is like way past the highest value I have. So 7.4 makes more sense. And now I'm just going to do a bunch of rote calculations. So first thing I'm going to do is subtract 5 minus 7.4. So negative 2.4. I'm going to pause the video and fill out the rest of that column. I would encourage you to do the same, and then I'll come back and start doing the squared column. All right, so the next column we're going to go ahead and square those values. And for negative numbers, don't forget to put parentheses around the negative. So parentheses negative 2.4, and then I'm going to press my squared button, and I get 5.76. So I'm going to pause. Feel free to do the same, and then when I come back, I'll fill out that last column. All right, for our next column, we're going to go ahead and take our deviation squared and multiply it by our probability. So it's this column times this column. So for that first calculation, I'm doing, whoops, I did not mean to do that. Hold on just a second here. 5.76 times 0.05, and I get 0.288. So 0.288. I'm going to go ahead and pause the video and fill out the rest of that column. Feel free to follow along and we'll compare values in a second. My next step is to add down that column, because remember that we are told to add up the deviation square times the probability. So I'm going to go ahead and set that up and then use my calculator. And I get 1.84 when I add down that column. In order to get my standard deviation, I need to take the square root of that value, because what I just found here is my variance. The standard deviation is the square root of the variance. So the square root of 1.84, so second square, and so we get 1.36 rounded. That makes sense. We know that our mean is 7.4, sits right about here, and there's not a whole lot of data values in either direction, and a lot of them are sitting at 7, which is pretty close to the mean, so I expect a relatively small standard deviation. My data doesn't have a very large range to begin with, and it's all pretty close to that mean. Now that we've seen the long way, let's take another look at the short way. So for example 2, a researcher wishes to determine the number of cups of coffee a customer drinks with an evening meal at a restaurant. Find the standard deviation for the distribution. In order to do this on a calculator, I'm going to treat this just like I would grouped data when I'm calculating means for raw data. I'm going to put my x values in list 1, I'm going to put my probabilities in list 2, and then I'm going to run one-var stats, where my list with my raw data is list 1, and my frequency list, where my frequency are list 2, because probabilities function the same as relative frequencies. So let's go ahead and do that on our calculator. So stat, enter, and then x is in list 1, p of x is in list 2. To run one-var stats, we go stats, calc, one-var stats. It already knows my data is in L1. I need to tell it that my frequency is in L2, and then calculate. And you'll notice it does a couple of things. One, it gives me that mean, or that expected value, which is nice. We can find expected values this way as well. It also gives me my standard deviation. And notice this is the one instance where it doesn't give you a sample value. When we're dealing with probability distributions, when that frequency list is decimals and they add to 1, the calculator knows this is a probability distribution and that it's a population value because this is all the possible outcomes. So this is one time the calculator can figure that out just from looking at the data. So our standard deviation would be 0.93 rounded. Again, that makes sense looking at the data. Very small range from 0 to 4, a mean that's sitting at about 1, and most of the data is clustered close to 1 with just a little bit out in the tail. So small standard deviation makes sense. All right, if you have any questions about what you saw in the video, feel free to drop by office hours on Thursday or send me an email. Otherwise, I'll see you in our next video.